Let me give you a function. In fact, a trigonometric function. There, y equals sine of x. Now, what is the range of sine x? That's easy. The closed interval -1 to 1. Now, let me restrict the domain of sine x. And I restrict it to the closed interval minus pi by 2 to pi by 2. And then I draw this graph. Now, observe the graph carefully. You can notice two important things. Firstly, for distinct values of x, the values of y are also distinct. You see that, right? Now, what does this mean? If I restrict the domain to the closed interval minus pi by 2 to pi by 2, then the function sine of x is 1, 1. Secondly, what is the range of the function? That is the closed interval -1 to 1. Now, sine x takes all the values between -1 and 1, including these two values as well. So, what does this imply? Every element of the range is an image of some x that is under the sine function. So, we can say that sine x is also an onto function. So, we have sine x is 1, 1 and it is onto under the domain minus pi by 2 to pi by 2. You know something? Sine x is also 1, 1 and onto in other intervals like these. -3 pi by 2 to minus pi by 2, pi by 2 to 3 pi by 2 and many more. So this means that we can have the inverse of the sine function in these intervals. And how do you denote it? Like this. You can call it sine inverse or arcsine. Now what is the domain of the arcsine function or the sine inverse function? That is same as the range of the sine function, which is the closed interval -1 to 1. What about its range? It can be any of these intervals. -3 pi by 2 to minus pi by 2, minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2, and so on. Now the branch of the arcsine function with the range minus pi by 2 to pi by 2, this is known as the principal branch. And the other branches? Well, they are just branches. So we can also write it like this. And we also have sine of sine inverse x equals x, where -1 is less than or equal to x is less than or equal to 1. Or we have sine inverse of sine x equals x, where minus pi by 2 is less than or equal to x is less than equal to pi by 2. Two important properties. Now we know the complete graph of sine x. There. You see it? Now we are going to use this graph to construct the graph of sine inverse x. So how do we do it? That's simple. We just exchange the x and y axis like this. So this is the graph of y equals sine inverse x. Let me also highlight the principal value branch. There. The closed interval minus pi by 2 to pi by 2. So this is what the sine inverse function or the arcsine function is all about. We know its domain, we know its range, the principal value branches, the other branches, its graph, and two simple properties.